Hello guys, welcome to May the Codes Be With You, and today we are doing a Leetcode hard problem and its magical number. Okay, so it states that a positive integer is magical if it is divisible by either a or b. Given the three integers n, a and b, they return the nth magical number since the answer may be very large. Return it modulo 10 ki power 9 plus 7. Okay, so here are the examples. So let's see what the example says. Okay, so I have made a list of all the numbers which are divisible by 2 or 3 and arranged it in ascending order. You can pause the video and see the list. So first example, n equal to 1, a equal to 2, b equal to 3. So we need the first magical number, which is 2. Now example 2 states n equal to 4, a equal to 2, b equal to 3. So a and b are same. So above list is applicable. So we need to give the fourth magical number. So the fourth magical number would be 6. So I hope you guys understand the question. Now let's see the approach. So for our approach, we would need GCD and LCM functions. So first function is GCD. So this is a simple GCD function. We have stated that if b equal to 0, return a, return GCD b a mod b. So it is a recursive function. You can see this function how it is calculated in the link below. Okay, now the second function we have used is LCM function. We wanted to calculate GCD just to calculate LCM by this formula. Okay, so let's go to our, so this is our second function. Now let's go to our third function. Now let us consider we have the values n equal to 5, a equal to 4 and b equal to 6. So we will use this example to understand a third function and why it is needed. So the multiples of a are 4, 8, 12, 16, 24, etc. These are the multiples of 4. And multiples of 6 or b are 6, 12, 18, 24, etc. Okay. So we have 12 here common and 24 here common. So let us understand why I explained this thing. So we have to find the fifth magical number. Let's take an arbitrary number 21, and the numbers which are less than 21 and are divisible by a are 4, 8, 12, 16 and 20, and for b are 6, 12 and 18. So for a we have 5 numbers which are divisible by 4 and less than 21, and for b we have 3. So we have 5 plus 3, 8. So let me write again 5 plus 3. Okay, so as you can see that 12 is repeating in for both a and b, so we will subtract 1 from it. So you are getting, we are subtracting the least common multiple of a and b from it. So 12 here is the LCM. So we don't want to count it twice, that's why we subtract it. So our formula would be numbers divisible by a, numbers divisible by b minus the LCM of a and b. Okay, let's take another number 14. I want you all to calculate for 14 first using this formula. Okay, so for 14 we have multiples of a, 4, 8, 12, we have 3, and for b we have 2, 6 and 12, and 12 here is repeating again. So 5 minus 1 is equal to 4. So this formula gives us the numbers which are less than the arbitrary number but are divisible by A or B. Okay, so here are the steps, and first here is the code, and first we write a function for LCM and GCD. Then we write the number equation function which we discussed in previous slide. Here is the code for that, and it calculates number of numbers less than n and are divisible by A or B. Now we define minimum, maximum and result. Then we calculate LCM of A and B and store it in a LCM variable. Okay, now for binary search we write a while loop with the condition minimum less than equal to maximum. Okay, so here is our while loop. Okay, then we calculate the midpoint between minimum and maximum using this formula. Okay, and then we use our number equation function to check if it returns a value less than n. If it does, then we simply do minimum equal to mid plus 1. That means we have to search it in higher numbers. If it does not, that means we have to search it in lower numbers, and the result becomes mid and maximum becomes mid minus 1. And if this condition fails, then we have to exit the loop and return this statement. Now let's check the code with the example to better understand. Okay, so we have taken n equal to 5, a equal to 4 and b equal to 6 like our previous examples, and I have put some debugging print statements. You can check their positions. Let's run the code now, and we get the following. So these are for very large numbers. Let's look for some smaller numbers to understand better. So okay. Here we have minimum equal to 16 and maximum equal to 30. So mid we have 23, and the result before the if statement is 31, and the number equation returns us 7, which is greater than n. So we go to the else part, and our result becomes mid and max becomes mid minus 1. So result is 23 and max is now 22, and minimum remains the same as we are going in the lower numbers. Now our minimum is 16, mid is 19 and maximum is 22. Okay, so result before if is 23 and number equation returns 6, which is still greater than 5. As binary search suggests, we still have to look in the lower numbers, so we change our maximum to mid minus 1 and our minimum remains the same. So our maximum becomes 18 and minimum becomes 16. Okay, so in the next iteration minimum is 16, maximum is 18, so our mid becomes 17, and result before if is 19 and number equation returns 5, which is still not less than 5. Okay, so we still go in the else part, and result is now mid and maximum is mid minus 1. So our maximum now becomes 15, sorry, maximum becomes 16 and our minimum is also 16. So our mid is also 16 and our number equation still returns 5, which is still not less than 5, and our maximum is 15 and our minimum is 16. So the while condition is not satisfied, so we break from the loop and return our result, which is 16. So here is the Leetcode interface, and here is our code and our 3 functions. Okay, now let's run the code to check it. Okay, it is accepted. Now let's submit. Okay, our code is faster than 100%. That's great. Okay, so this was the nth magical number problem. Thank you guys, and may the codes be with you. And if you like this video or it helped you in any way, then sub to the channel would be great. And thank you again.